Today we're going to focus mainly on analysis of variation. Excuse me. And we got our first topic, ANOVA. And let me bring up the book. This is specifically one-way ANOVA, comparing several sample means. And we're not going to go into all the different items that are in the book. We're going to focus on how to find it using technology. They'll go through here, they'll give you some examples and so forth. Okay. I'm looking for an example to show. Let's go down to the problems. And go back here faster and go to the problems. Okay. Now we get down to here. And we got site 1. We got site 2. And site 3. 61, 34, 25, 12, 79, 55, 20. Then site 2, 25, 18, 54, 67, 12, 36, 69, 27, 18, 14. Now in general, when we come up with a null and alternate hypothesis, our H naught is always where the means, population means of all of them are equal to each other. So this would be moose 1 is equal to moose 2 is equal to moose 3. H1 is at least 2 of the means are not equal. Now put data into Excel, we just did that. Then it says do a data analysis, ANOVA, single factor. So go to the data tab, go to data analysis, and ANOVA, single factor. And click OK. Now when you do your input range, you want to make sure you highlight to the very bottom of your longest row column. And if you got labels, like I do up top there, then you want to have this marked. If you don't, then you want to unmark that. And let's see, what is the level of significance? 0.01. Okay. And I already got 0.01 here, so I'd change that to 0.05 if it's something different. Let's make sure that's still correct. Okay. And then click OK. Now let me make that a little bit bigger. There we go. Excuse me. Here's our alpha is equal to 0.01. Here's what I said. H naught, moose of 1 is equal to moose of 2 is equal to moose of 3. And not all the means are equal. At least 2 are different. Now, some of these values, when they ask about them here, you don't need to really worry about that. Some of them are given to you by the program. So when you come here, you can find the values on here. And there's 260.14. 538.87. 538.87 is right there. See the MS column? That corresponds to the MS column here. Degree of freedom. So even though I think this says this is from for this from T84, I thought this was a mini tab display. You'll find the values the same. Now here they give you an approximation for p-value. What you find in Excel is it'll give you an exact value. And that corresponds, you see down here, it says approximately 0.627. I guess this is mini tab. This just says from T84, it's 0.6270 right here. And that's it right there. Doesn't really say what to do. Oh, there's the answer. Click there. No. Oh, they have it over here in test decision. It says do not reject H0. Well, from my spreadsheet, if p-value is less than alpha, it isn't. If p-value is greater than alpha, then that says we accept H0. And if we accept H0, that means we reject H1. But that's how you would do it on ANOVA. Now, book go through a lot of by hand calculations, and you're welcome to do that if you want. But you can see that technology makes it a lot simpler. Now let's go and look at the two-way. So we got our two-way ANOVA here. And let me bring up the book again. And let's look at number 5. We got cable, primetime TV, prime, radio, newspaper, and magazine. Over here, less than 20,000. 20,000. 39,999. 40,000 to 74,999. And 75,000 or more. Okay, it's got 78, 112, 89, 80, 91, 97, 105, 100, 97, 100, 113, 92, 106, 111, 105, 121, 94, 107, 121, and 105. Okay. Now for our two-way, we come up with the null and alternate hypothesis, and here's where we're considering it at the row level. Here's where we're considering it on the columns. And then here, just we're talking in general about the factors. Now, I'm not going to go into all the details of that, but I want to show how to use the technology part. So that really isn't in the book here. I think the book's pretty good on explaining it, but it doesn't really talk about how would you do it in Excel. Okay. Now I don't have to have those highlighted, but if I do data analysis, I choose ANOVA 2-factor without replication. Click OK. You need to pick whatever. So I'm going to pick that range data there. I do have labels, so I click that. 5%. Do I want 5%? Yeah, this is one's 5%. And I click OK. And a little bit larger here. That's not too exciting there. It tells us how many income levels we have and how many media types. Okay. Here's your I don't think it gives us that. Yeah, it does. Well, maybe it doesn't. Oh, right here. 2.77. So it's given us the F value, and P value is 0.088, which is right here. Now at 5%, again, we're still comparing. So P value is greater, so that says we do not reject H0. Basically, we accept H0, reject H1. So the data do not indicate any differences in the population mean index according to the income level. Income level. Well, the income level's over here. And notice that's what it specifies. It specifies rows. So this was comparing it at the row level. Now here's based on media. Okay. It tells us 0.03 right here for our F value. P value is 0.998. That corresponds to this right here. That P value obviously is greater than 5%, our level of significance. So it says we do not reject H0, we accept H0. And then according to the corresponding part that goes with that. But that's how you would do the two-way ANOVA. Now, that's out of chapter 10. When you get to chapter 11, Excel's not going to be very helpful with it. You got some different tests being done here. It'll walk you through what exactly to do. Sometimes it may be counts. See how many plus signs you see, how many plus and minus signs you see. Gives you the proportion, so forth. And I get down to here. Now this is where you can use Excel. You know, for the most part, you just apply the formula as is. But when I start talking about the standard normal distribution table, you can use table in the appendix to find your p-values, or you can use technology. Now sometimes you have to play with it a little bit to get the right value. Like if I do equals norm dist 2.31 0.1 true. You notice I get a 0.989556. And their p-value is 0.0104. Well, if I were to, instead of doing strictly that, I'd do 1 minus that value. If my formula looked like this. because when you're doing the 2.31 norm dist is returning the area to the left, and what we're wanting, as you can see from the picture, we're wanting this area to the right. So then if I select it, you see the p-value of 0.0104, 0.0104. Now it may not come out perfect. Some of those p-values you see in a book are based upon their coming out of a table in the back, an appendix, which is limited by the decimal places it's rounded to. I think there was one example where you had to multiply it by 2. I'm not sure if it's this one. Yeah, this was this one. Since this is 2 tails, then once you come up with your p-value here, you have to multiply it by 2. So if I were to put that in my calculator, it gets a p-value equals norm dist negative 0.7301 true. You see it gives me my 0.2327. This right here. But it's giving me just the area to the left where this far left pink is. But I need both, so I had to multiply by 2 since it's symmetric. And so then that would give you your p-value. So some of these procedures in the book, you have to do part of it by hand, but you can use technology to get some of the p-values. So using everything we're seeing up to now in the course, for finding a p-value using technology can be done here. Now that's really all I was going to cover. I wanted to leave plenty of time for any questions that people had. As you're going through this, if you have a problem in the book that you want a YouTube video created on how to do it in Excel, you merely have to send it to me and say, hey, could you create one out of this one out of the book, and I'll create it. I won't create any out of the actual assignment, but any problem in the book, if you want to see how to use technology to do it, as much as you can. Like I said, some of these where you're counting, then get back up there. This right here, how many plus signs do you see? You can probably do that in Excel, but it's probably overkill. It's much easier just to add them. But anyway, feel free to contact me, and I'll upload any examples you need.